In this video, I'll be going over benzene reaction part 2. So the first reaction I'll be talking about is nitration. So specifically, if you have a benzene and you react it with HNO3 as well as H2SO4, then you're going to create a benzene with NO2 on it. So with any benzene reaction, there are three main steps. The first step is generating your strong electrophile. So, if we start out with HNO3, what that looks like is this. You have a nitrogen in the center, you have a double bonded oxygen here. In addition, you also are going to have an oxygen with a negative charge, as well as an oxygen with an OH. And keep in mind that this OH is probably the most important oxygen. In addition, H2SO4 is going to look like this. So you have two double bonded oxygen as well as two alcohols. So mechanistically what happens is this lone pair on the OH is going to come and deprotonate this hydrogen here. So what ends up happening is you're going to now create a molecule that looks like this. You're going to have H with the plus charge, and you're going to have oxygen with a negative charge. So as you can kind of see here now, this looks like a water molecule. So this water molecule is now going to leave, which gets rid of this plus charge. This negative charge, this electron is going to go here, thus creating this molecule. So now we have oxygen, double bonded oxygen to the nitrogen here, a plus charge here, as well as H2O. So as you can see here, this is now our new strong electrophile. So after creating our strong electrophile, the next step is doing the electrophilic attack. So specifically, what ends up happening is we have our benzene here, and we have NO2, right? So what pretty much mechanistically happens is that this electron is going to attack this central nitrogen here. However, this electron here is going to go onto this oxygen now in order to obey the octet rule. So now we're going to form a molecule that kind of looks like this. We have NO2 here, right? Don't forget that we have a negative charge here, as well as a plus charge here, as well as a plus charge here, right? So as you know, next, what ends up happening is now we need to do some kind of elimination reaction to get rid of this plus charge, right? And don't forget we have a hydrogen here. So in order to do that, we can use some kind of base to do an elimination reaction. So if you remember from our previous slide, we have a lot of excess water from when we created our strong electrophile, right? And this is a pretty good base to now do an elimination reaction. So what's going to happen is that this electron is going to deprotonate this hydrogen here, and this hydrogen electron is going to reform aromaticity, right? So just based on those arrow pushing mechanism, now we're going to reform a molecule that looks like this, right? And shorthand, you can just write NO2, and that is the general mechanism for nitration reactions. So the next set of reactions I'm going to talk about is sulfonation. So if you have a benzene and react it with SO3 and H2SO4, you're going to end up creating a benzene with an SO3H molecule on it. So in regards to the mechanism, sulfonation is a bit easier than nitration. So with sulfonation, you begin with SO3. So what that looks like is S with 3 double bonded oxygens. So basically, when you react it with H2SO4, which as we know from nitration looks like this, what ends up happening is that one of these double bonded oxygen can directly attack this hydrogen here. So as a result of that, we can create a molecule that looks like this now. So now we have an OH here, an alcohol, as well as a positive charge in the sulfur, since it wants 6 bonded electrons, not 5. In addition, don't forget that now we have O minus SO3H. And as you can kind of predict, this base is going to be the one that does the elimination reaction. So continuing on the mechanism, if we have some kind of benzene like so, and we react it with SO3H, what ends up happening mechanistically is kind of, self-explanatory. So, specifically, this one of the electrons on the benzene is going to attack the sulfur, thus producing this molecule now. Right, and we know that there's going to be a plus charge here. And in order to restore aromaticity, we have to use some kind of base to deprotonate the hydrogen and to basically use those electrons to reform aromaticity. So what we know is that from the previous slide that OSO3H is going to be the one that does the deprotonation. So if we have OSO3H, what ends up happening is that this oxygen is going to deprotonate this hydrogen, and this electron is going to reform aromaticity. Thus, when we draw the final molecule, it's going to look like this. And this is generally the general mechanism for sulfonation. However, in addition to the previous mechanism, there is also an alternative mechanism that some schools may teach. So, if we have a benzene, right, we technically don't need to generate the strong electrophile first for this specific mechanism. So, we have our benzene and we have SO3. Like so, right? And what ends up happening is that this benzene can just directly attack the SO3. Although it's not the most favorable, this reaction can slightly proceed forward. So if we do so, we now create a molecule that looks like this. Right, So as you can see here, we now have a negative charge oxygen as well as this plus charge on the benzene. So kind of the next step is if we want to get rid of this plus charge, we're going to have to do some kind of elimination reaction. And as we know from time and time again, we always use our base. So specifically, we can just directly use OSO3H, which came from H2SO4. Right, and basically what ends up happening is this oxygen is going to deprotonate this hydrogen, thus reforming aromaticity here. So now we form this benzene with, that's aromatic. However, we still have this negative charged oxygen that we need to take care of now. So kind of for the last step, we need to get rid of this negative charge, as I said. So the way we can do so is by reacting it with H2SO4. So we always use this molecule, H2SO4, as you can kind of see, right? And once we react it with H2SO4, what ends up happening is that this negative charge is going to deprotonate this hydrogen, thus reforming this molecule, SO3H, as well as SO3H minus, right? And kind of this molecule now can be used to continue producing, this molecule here now. And that's the alternative mechanism for sulfonation.